And the concept of collinear can be extended like this also, that is vector AP can be taken as lambda into vector AB. Vector R is equal to vector A plus lambda into vector B minus vector A. Angle between any two lines is given by B1 dot B2 by magnitude of B1, magnitude of B2. Direction ratios of the first vector with respect to the second vector with respect to its components must be in proportional. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study one more equation of a line which is passing through a given point. Again, this will be an important derivation for your examination under 5 marks category. So, equation of a line passing through two given points. So, here I have taken a three-dimensional axis x, y and z axis with origin O. Have drawn a vector which is passing through 2 points, vector A and vector B. And let P be any arbitrary vector so that its position vector is vector R. Now, whatever I have drawn on the diagram, the description has to be written. So, consider 2 points A and B whose coordinate may be x1, y1, z1 and B is x2, y2, z2 respectively. Let a line passes through the 2 points, vector passes through 2 points, vector A and vector B, and let P be any arbitrary point on the vector AB. Now, from the diagram, we can clearly say that A, P, B are collinear. So, that is A, P, B are collinear. So, that is why I can write this as vector AP. So, if I say this as vector AP, so and vector AB are collinear. That means I can write it as vector AP is equal to lambda into AB, because for the reason A, P, B are collinear. All are on the same straight line or all are lie on the same vector. And the concept of collinear can be extended like this also, that is vector AP can be taken as lambda into vector AB. Now, what is AP? AP can be written as vector OP minus vector OA, that is lambda into vector OB minus vector OA. So, now vector OP is nothing but vector R. So, vector R minus vector A lambda into vector B minus vector A. Thus, we have vector R is equal to vector A plus lambda into vector B minus vector A. So, this is the vector form of the given equation of line. So, now we have arrived at the vector form of the equation. Let us write the Cartesian form of this equation of a line passing through the two given points. So, here let me take, let x1, y1, z1 and x2, y2, z2 represents the coordinates of point A and B respectively. Let P be any arbitrary point whose coordinates be x, y, z. Then according to our vector form, we have vector R is equal to vector A plus lambda into vector B minus vector A. So, now vector R is here we have xi plus yj plus zk, and vector A is x1i plus y1j plus z1k plus lambda into vector B. So, vector B is again here x2i plus y2j plus z2k minus x1i plus y1j plus z1k. So, now what we will get here, we have xi plus yj plus zk. So, let us take the components here. So, we have here x1. Here we can write in the form of x2 minus x1, that is lambda into x2 minus x1. So, x1 plus lambda into x2 minus x1 I. So the same thing we will get for y components, that is y1 plus lambda into y2 minus y1 for component j. Next, the same thing for z, that is z1 plus lambda into z2 minus z1 k. Now again, we can equate the components here. So we get x is equal to x1 plus lambda into x2 minus x1. Y is equal to y1 plus lambda into y2 minus y1. Next, z is equal to z1 plus lambda into z2 minus z1. So we can shift x1, y1 as well as z1 to the left hand side. So we will get x minus x1 and x2 minus x1 can be written in the terms of denominator. x2 minus x1 is equal to lambda. Similarly, here we get y minus y1 by y2 minus y1 is equal to lambda, and here we get z minus z1 divided by z2 minus z1 is equal to lambda. Now all these ratios are equal to lambda here. So therefore, I can conclude here x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So this is the Cartesian form of the equation of a line passing through two given points. Find the vector equation of the line passing through the points minus 1, 0, 2, 3, 4, 6. So here we need to find out the vector equation. To form a vector equation, I need vector A whose coordinates are given, and here I have vector B whose coordinates are given. Now we know that vector R is equal to vector A plus lambda into vector B minus vector A. So vector R is nothing but xi plus yj plus zk. Now vector A is, we have minus I, 0, j is nothing but 0. So plus 2k we will write, plus lambda into, we need to take b minus a. So b minus of minus 1 becomes 4. So 4i. Next we have 4 minus 0. So that is 4j. Next we have 6 minus 2, that is 4k. So this is the vector form of the given equation. Next, find the vector and Cartesian equation of the line that passes through the points 3, minus 2, minus 5, 3, minus 2, 6. So let me take this as vector A and this as vector B, the coordinate form. Now we know that the vector form is vector R is equal to vector A plus lambda into vector B minus vector A. Now this is the vector form. So we can write vector R as xi plus yj plus zk is equal to vector A is 3i minus 2j minus 5k plus lambda into B minus A. 3 minus 3 is 0. Minus 2, minus of minus 2 becomes plus 2, 0. 6 minus of minus 5, which becomes 6 plus 5, that is equal to 11k. So this is the vector form of the equation. Now coming to the Cartesian form of the equation, we have x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Now this implies, so we will take x1, y1, z1 as 3, minus 2 and minus 5. Again x2, y2, z2 is 3, minus 2, 6. So x minus x1 means it is x minus 3. x2 minus x1 means 3 minus 3, it is 0. Next y minus y1 means y plus 2 we have. y2 minus y1 is minus 2 plus 2 becomes 0 here. Next z minus z1 is z plus 5 we have. z2 minus z1 is 6 plus 5 becomes 11. So this is the Cartesian equation of the given line. Next, Find the vector and Cartesian equation of the line that passes through the origin and 5, minus 2, 3. So, origin means we have the coordinate 0, 0, 0. So, clearly we can say vector A is completely origin and we have only vector B. So, what is the Cartesian and vector form? First, we will write the vector form. Vector R is equal to vector A plus lambda into vector B. R is xi plus yj plus zk. Vector A is clearly the origin. So, 0i, 0j, 0k, which is a null vector. So, no need to write. Now, we will just write lambda into, this is vector B minus vector A. So, vector B minus vector A is again 5 minus 0, 5, minus 2 minus 0, minus 2, 3 minus 0, which is 3. So, this becomes 5i minus 2j plus 3k. So, this is the vector form. Now, Cartesian form, we know that it is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Now, clearly we have x1, y1, z1 as origin, which is 0. x2, y2, z2 is 5 minus 2, 3. So, therefore, we get x by 5 is equal to y by minus 2 is equal to z by 3. So, this is the Cartesian equation of the given line. Next, we have angle between two lines. So, angle between two lines. Suppose you have two lines L1 and L2, and if they intersect each other, they are passing through the origin and with the direction ratios A1, B1, C1 for line L1, A2, B2, C2 for line L2 respectively. The angle theta between them is given by, the angle is given in terms of cos theta, that is A1, A2 plus B1, B2 plus C1, C2, which is nothing but the dot product of two vectors, and divided by square root of a1 square, b1 square, c1 square, square root of a2 square plus b2 square plus c2 square. Suppose if I say here, let line L1 is a vector of the form a1 plus lambda b1, okay, and line L2 is a vector form of a2 plus lambda b2. So, this is the vector form of the two lines. Then, the angle between these two, cos theta, can be written as the dot product of b1 and b2, that is a vector which is parallel to the line. So, therefore, it is b1 dot b2 divided by magnitude of b1, magnitude of b2, and we have here modulus. So, B1 dot B2 is nothing but again A1 A2 plus B1 B2 plus C1 C2. That is the dot product of these two vectors here. And this is nothing but the magnitude of vector B1 and this is nothing but the magnitude of vector B2. So, thus the angle between any two lines is given by B1 dot B2 by magnitude of B1, magnitude of B2. It is same as the cos theta using dot product. So, where you are finding the dot product of A dot B over magnitude A, magnitude B. So, here we have dot product of two vectors B1 and B2 over magnitude of B1, magnitude of B2. And we know that angle is given in terms of cos theta, and if you want theta, you should take cos inverse of the given value. So, thus I can say this is the vector form which is easy to remember, and this is the Cartesian form where its direction ratios are given. Now, here very two important things to note, that since we are calculating cos theta here, based on cos theta we have two observations. Suppose whenever theta is 0 or theta is 90 degree, cos 0 is 1 and cos 90 is 0. What does it means? Two lines with the direction ratios A1, B1, C1 and A2, B2, CT respectively perpendicular. We know that if two lines are perpendicular, their angle must be a 90 degree. Then by this equation, which equation? By this equation, if cos 90 is 0, then the denominator can be sent to the LHS which becomes 0. So, we will get A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, that means what? If the dot product of the two vectors or the two lines are 0, that is A1, A2 plus B1, B2 plus C1, C2 are 0, then the two lines are perpendicular to each other. Again, if they are parallel, every time I have said you that whenever two vectors are parallel or whenever two lines are parallel, then or whenever you have to prove that 3 points are collinear, so that take them as two different line segments, then the ratio of the components must be equal. That is A1 by A2, B1 by B2, C1 by C2. That is the direction ratios of the first vector with respect to the second vector with respect to its components must be in proportional. So, to show that the two lines are perpendicular, show that the dot product of their components is 0, and to show that the lines are parallel, take the ratio of their components and show that they are equal or they are in proportion. Next, show that the lines x minus y by 7 is equal to y plus 2 divided by minus 5 is equal to z by 1, and x by 1 is equal to y by 2 is equal to z by 3 are perpendicular to each other. So, I already said you to show that the two vectors are perpendicular, we need to show that the dot product of the two lines where whose direction ratios are A1, B1, C1 and A2, B2, C2 are 0. So, here the Cartesian form of the lines are given, that is x minus 5 by 7 is equal to y plus 2 by minus 5 is equal to z by 1. So, here vector A, we have vector A here, vector A is 5i minus 2j and vector B is 7i minus 5j plus k. And for the second line, that is x by 1 is equal to y by 2 is equal to z by 3 here. So, the vectors here is given as 0 because x1, y1, z1 is 0. So, therefore, it is a null vector. Let me take this as vector A1, vector B1 and let me take this as vector A2, vector B2. So, what is vector B2? We have I plus 2j plus 3k. Find the angle between the two lines. Take the dot product of two vectors, that is B1 dot B2 and their magnitude in the denominator. But here they have given, we have to show that they are perpendicular to each other. To show that the two lines are perpendicular to each other, it is enough to show that their dot product is equal to 0. That means we need to find out B1 dot B2. So, let us find out B1 dot B2. So, multiply corresponding components. Now, 7 into 1 is 7, minus 5 into 2 is minus 10. 1 into 3 is 3. So, 7 plus 3 is 10. 10 minus 10 is 0. So, this is equal to 0. So, we got B1 dot B2 is equal to 0. That means A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So, that means what? We can clearly say that two lines are perpendicular. Find the angle between the pair of lines x by 2 is equal to y by 2 is equal to z by 1 and x minus 5 by 4 is equal to y minus 2 by 1 is equal to z minus 3 by 8. So, clearly we need to find out what is the direction ratios of line 1 and line 2. So, let us see now the direction ratios of x by 2 is equal to y by 2 is equal to z by 1 is 2, 2, 1. So, this is your A, B, C, which are direction ratios. Next, the direction ratios of x minus 5 by 4 is equal to y minus 2 by 1 is equal to z minus 3 by 8 is, so we have 4, 1, 8. Now once you know the direction ratios, you can use the formula, that is cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 whole divided by square root of A1 square plus B1 square plus C1 square root of A2 square plus B2 square plus C2 square. So now we have A1, B1, C1, A2, B2, C2 here, which are the direction ratios. So let's write here cos theta is equal to A1, A2, 2 4s are 8 plus B1, B2, 2 1s are 2 plus C1, C2, 1 8s are 8 divided by square root of, we have 2 square plus 2 square plus 1, which is 4 plus 4 plus 1. Next we have 4 square plus 1 square plus 8 square, which is 16 plus 1 plus 64. So now let's see this. So 8 plus 2, 10, 10 plus 8, 18 divided by, so here we have 4 plus 1 plus 4, which is nothing but 9. Root 9 can be taken as 3. Next we have here 64. 64 plus 16 becomes 80, 81. So root 81 is nothing but 9. So 9 ones are 9, 2s are. So we will get the value as 2 by 3. Now we have cos theta is equal to 2 by 3. So therefore theta is equal to cos inverse of 2 by 3. So this is how you are going to find the angle between any two lines. So whenever two lines are given, just find their direction ratios, use the formula where cos theta in terms of direction ratios are given. You can also calculate it using the vector form, that is b1 dot b2, just find the second vector b1 b2 and take the magnitude which is one and the same. Here b1 dot b2 is nothing but your a1 a2 b1 b2 c1 c2. Magnitude of b1 is nothing but a1 square plus b1 square plus c1 square. Magnitude of b2 is nothing but a2 square b2 square c2 square, which is one and the same. So that helps us to give you the angle between the two lines. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.